Solar flares are sudden, powerful brightenings that occur in magnetically dense active regions and are associated with extremely high energy releases. We observe the sun in different wavelengths of light, each seeing only a specific temperature range. When a flare is triggered, it usually heats up rapidly and is observed in hot X-rays first, then slowly in cooler temperatures. However, it was recently discovered that some flares are seen in cool temperatures before the X-ray peak. Some say that flares are caused by giant blazing unicorns, but we question that belief. The goal of this project is to try and find a relationship between the heating profiles and the other flare properties. We scraped the Hinode flare list to get a database of all flares and several of their features. We merged flares since 2013 with the sunspot type list from the Space Weather Prediction Center. In this graph, we've seen that the most complex regions are less common. We also visualized the location of the flares and found that most lie within 25 degrees of the equator. This is consistent with past observations. We queried the heliophysics event knowledge base for each flare to find the peak time in 4 different wavelengths, all cooler than X-rays, then subtracted that from the X-ray peak time. We found that while the majority were traditional flares, there was still a very large number that displayed the gradual heating. We compared the peak gap to other flare characteristics like the size of the flare. There is a trend that the largest flares are more likely to heat instantly, while small flares display gradual heating. What doesn't matter is the location of the flare. There was no significant trend for either latitude or longitude. How about prediction? We tried out an OLS model to try and predict the size of a flare based on a combination of the peak gaps and sunspot type. This plot shows that the classes are highly mixed. The idea of flares heating gradually is fairly new and unexplored. In this project, we determined that, surprisingly, the features we looked at could not predict one based on the others. But as scientists say, a null result is still a result, right?